All right, we're back. We're on page 100 of math analysis. Crazy. I mean, crazy if you've been with me from the beginning. In my mind, it's crazy that I've recorded 100 pages of this. Weirdly, I actually started recording these notes for whatever reason on page 209. So I really started page 209. I went all the way to the end. How many pages are there? 329. Then I looped back around. So page 100 for you is amazing. This is really page 220 something for me, and I never in my life imagined doing this. But then then the world changed, and so that's what I've been doing. So let's see if we can do this. So we're just still simplifying things. Simplify, find the exact value if possible. So it might not be possible. So I look at them, and I'm looking for commonalities, things that I expect. So I see pi over 10s and pi over 15. So I have sine, cosine plus cosine sine. So I know that that's going to be the sine of the sum. So sine of like a plus b. So pi over 15 plus pi over 10. And that's the sine of, we're going with 30. 2 pi over 30 plus 3 pi over 30, 5 pi over 30. So it's actually the sine of pi over 6. So this craziness is just 1/2, right? So you just find your angles, see if they fit a formula. If they do, you're good. If they don't, you probably have to do more work. So let's see, this is cosine, cosine, sine, sine. So I'm looking for the same angles if possible, because it's just easier if they're there. If they're not there, we have options. We can use reference angles. We can use cofunctions, like a lot of options. And I think there's a couple, at least one example, but maybe more, where we're gonna have to deal with that. So this should be cosine, cosine minus sine, sine. This is the cosine of a plus b. 19 pi over 30. So that's 6 plus 19 is 25 pi over 30. And then that's the cosine of 5 pi over 6. And so cosine of 5 pi over 6 is negative radical 3 over 2. So like we don't know what the intermediate values are at all, but we do know that if we somehow combine them all, like multiply and then take the difference, we're going to get negative radical 3 over 2, which is pretty crazy, but it definitely will work out. Now this one's in degrees, and I don't know why, and I kind of object, but it's 2 tan, so just find the same thing. 2 tan a over 1 minus tan squared of a. So this is a double angle for tangent. This is the tangent of 2 times 15 degrees. So that's the tangent of 30 degrees. And the tangent of 30 degrees is the tangent of pi over 6, which is radical 3 over 3. So like, they're not that bad. I say that, and then I bring you this. Cosine, so negative, look how many angles there are. So there's this, but then when you go searching, it's not there again. There's this, but when you go searching, not there. We got this, but again, it's its only version. And then we have this. So none of the angles repeat. But what's weird about this is that they are all cosines. And that we don't know any formula that's like cosine, cosine plus cosine, cosine. We don't know a formula like that. So when in doubt, which I'm definitely in doubt right now, what I like to do is rewrite everything in terms of reference angles. So I'm going to, how much room do I have? I'm going to do it kind of like over here and say that the cosine of 5 pi over 9. So what is the reference angle of that? The cosine of, so this is quadrant 2, because it's bigger than 4.5 pi over 9, which would be pi over 2. And it's 4, the reference angle is 4 pi over 9. So this is the same as the negative of the cosine of 4 pi over 9. And I'm just going to leave that for now. So cosine of 5 pi over 18 is already done. Cosine of 5 pi over 18. And then cosine of 17 pi over 8. So this is done. Cosine of 17 pi over 18. So 17 pi over 18. It's definitely quadrant 2. And your reference is definitely just pi over 18, because that's how short you are. So this is the negative of the cosine of pi over 18. Just kind of like trying to simplify things a little bit. And then 16 pi over 9. So the cosine of 16 pi over 9. So 16 pi over 9 is 2 pi over 9 away from 18 pi over 9. So this is going to be in quadrant 4. And the reference angle is going to be 2 pi over 9, that's what you would need to get to 2 pi, which is 18 pi over 9. So this will be just cosine of 2 pi over 9. All right, so now, was there anything helpful in there? I mean, maybe. What I'm going to do now is cofunctions, just to see. So I'm trying to get like the same thing to show up. So I'm going to do cofunctions, so I need a little space. So this will be the negative of the sine of pi over 2 minus, so I have pi over 2 minus 4 pi over 9. And if we work that out, that's 9 minus 8 is pi over 18. Is that helpful? Pi over 18. Ooh, pi over 18. I have a sine of pi over 18, and I have a cosine of pi over 18. Things are looking okay. And then I'm going to do the same sort of thing here and say this is equal to the sine of pi over 2. So 9 pi over 18 minus, so 4 pi over 18, which is 2 pi over 9. And if we look, we have another 2 pi over 9. So the secret here, and it's not a secret, but like the secret is reference angles and then cofunctions. Use reference angles and cofunctions, and you will be able to reduce, if it's going to work, you'll be able to reduce it down to a problem you can actually do. So now let's make some substitutions. I'm trying to like clear some space. Let's put that down there. All right, direct substitution. So it's going to be negative, and then negative sine of pi over 18. Cosine of 5 pi over 18 is going to become sine of 2 pi over 9. So sine, and now the next two are going to be cosines, which is good, minus negative cosine of pi over 18. And then the cosine of 16 pi over 9 is the cosine of 2 pi over 9. Okay, so far, pretty good. I'm gonna like box this off kind of as like just my work maybe, if it lets me. All right, so far we're on our way. So what does this clean up to? This cleans up to, I'm gonna write it as, it's cosine plus sine. So I'm gonna write cosine pi over 18, cosine 2 pi over 9, which I should be writing as 4 pi over 18, just to like simplify things, but, and then it's gonna be plus the sine of pi over 18, the sine of 2 pi over 9. Okay, so cosine plus sine, whew, is going to be the cosine of a minus b. So this is the cosine of pi over 18 minus 4 pi over 18, which is the cosine of negative 3 pi over 18, which is the cosine. Is there anywhere near enough room for this? Not really. Well, I mean, I'm getting it in, but like cosine's even, so this is the same as the cosine of pi over 6. And the cosine of pi over 6 is radical 3 over 2. Holy cow. So that, I mean, I think is probably right, because like, if you get yourself a famous angle when a problem says you should get a famous angle, you probably did it right. Let's check them all on the calculator. So you can check these by directly typing them in. So that's what I'm going to do. And then I'm just going to cut this video here and pick up in the next one. So I'm typing it in, pi over 15, cosine pi over 10. The way that I switch always puts the cursor like right in the way, and then I never remember to move it, or it just like doesn't bother me enough. I imagine that really bothers some people who watch these. Pi over 10. Oh, what? Okay. I don't know what is happening here. You know what? Let's do a little, let's do a t collect, because it feels like that should be it. Get an exact value. No, what? How about t expand? I mean, it's definitely 1/2. Like it, nope, nope, nope. So control enter gives me 0.5, which is what I was expecting. I don't know what's going on there. Let's do this. Cosine. You know what we could do is we could do t collect, I think, of just like sine x cosine y plus cosine x sine y. So instead of like plugging in specifics, get this and then do such that x equals pi over 15 and y equals pi over 10. There you go. Fake your way through it, right? You gotta know. That's why you gotta know multiple approaches to things. I don't know how excited I am for the rest of these, but let's see. Cosine pi over 5, cosine 19 pi over what? 30 minus sine of pi over 5, sine of 19 pi over 30. Gosh, why? All right, let's do it again. Let's change this to a y. Let's change this to an x. Let's change this to a y. It's like, will I ever learn though, is the thing. I don't think so. T collect. Like as in, I think I'm just gonna keep doing the same thing every time. X is pi over 5 and y is 19 pi. It's like you have to force the order of operations to somehow do it the way that you would. All right, I'm gonna have to convert this to tan of 15 pi over 180 because I'm not switching to degrees, no way. So I encourage you also to do this. This is the professional way. Oh, look at that, just spits it out. I don't know why. All right, and then our last one, I'm a little concerned about because I don't know how I'm gonna like fake my way through this because I have like X, Y, and Z, but let's find out. So negative cosine 5 pi. Another option is, and what I'm gonna do, if it doesn't work, is I'm just gonna use decimal and see if it's the equivalent decimal. Minus cosine of 17 pi over 18, cosine of 16 pi over 9. So that's really interesting that it like changed it to that. And then if I do t collect, okay. It gave us radical 3. Why on earth was the like most challenging one that we did, the one that the calculator just like rampaged through with no problem? I don't know. But anyway, I'm definitely gonna stop this here and I will be back in the next video to do the next part of the page. So I will see you there. And I hope you're finding these kind of helpful.